Hello everyone, this is Dilip. In the last couple of videos, we have seen various techniques that we can use in neural networks. Now, putting it all together, we'll have an implementation notes which we can refer while writing neural networks code. First, we need to choose the type of neural network, the number of hidden layers we want, and the number of nodes in each layer. So here you can see here for this example we are taking 2 hidden layers, and in first hidden layer we are taking 4 nodes, and second hidden layer we are taking 3 nodes. Then we'll go for the steps for implementation. So randomly initialize all the weights in the Gaussian distribution between minus epsilon plus epsilon. It means any value you can choose, but make sure that all the parameters are randomly initialized within the Gaussian distribution of that parameter. It can be -1 to +1 or -3 to +3, like that. Next, we implement code to do forward propagation and calculate h of x. So this is the final output, whatever we get after we do forward propagation. So this will be a function where we give it input parameters and variables, which will help us in deriving h of x. And again, another function you write to calculate the cost function j of theta, since j of theta again involves h of x. So inside this function, we'll do a callback to this function whenever required. And then we implement a code to compute cost function derivative using the back propagation. So this will also be a function. So in total, we have 3 set of functions, one for calculating h of x, another for calculating cost function, and another for calculating derivative of the cost function. Then what we do gradient checking. So we calculate the derivative in the back propagation step, in step 4, and then we use gradient estimate to calculate the derivative using the cost function. So this will help us to validate our back propagation. So how we use gradient estimate, you can check out my last 2 videos. And then once we are sure that both of these values are nearly equal, so the gradient estimate derivative and the gradient calculated using our back propagation, if both of them are nearly equal, then we can switch off gradient checking, because we know that our back propagational code is working fine. Then we input the parameters, the randomly initialized parameters, initial theta, the cost function for calculation, pseudocode, sorry, not pseudocode, the code, whatever we wrote for doing the cost function, and the derivative function. So these we can input to gradient descent or other advanced optimization algorithms to derive optimal weights. As you will see in the examples which you will see in the later videos, in Python there are a lot of Keras implementation, and it's available already, where you just need to select the number of layers and number of nodes. And most of these algorithms, whether cost function calculation or initializing the theta values or the derivative calculation, so all of these, if any algorithm you choose, like stochastic gradient descent, these are all already available within the libraries. So you just don't need to do anything. You just need to initialize the number of layers you want and number of nodes in each layer, and automatically the entire libraries will take care of that. But if you want to implement it, this is the way to implement. And one major example of neural networks in early 90s is this all-in robot driving system, which is done on a truck mounted with a color camera. So somewhere around 1992 and 1994, Dean Pomerleau of the Carnegie Mellon University has implemented a autonomous driving truck. And this truck can drive itself using the neural network. So there will be a person who is manually doing the steering, and whenever he is rotating the steering wheel based on the road, and his steering wheel is given as inputs to the neural network, and those are like samples for the neural network, and based on that it has learned, like if the road is like this, how to react, if the road is like this, how to react, how to rotate the steering wheel. So based on that, after a while the truck is able to rotate the steering wheel itself instead of manual input. So that is how this worked. And one really interesting thing you will find is this truck is driven by neural network with only a single hidden layer. So that's how powerful the neural networks are. The link for this paper, I'll put it in the description. You can check out the paper. It's a very interesting read, even though it's from 1994. So thanks everyone for watching the video. Bye.